response to reach 50% of the final value in first time. So this is the delay time. So whenever we reach a 50% of the response first time, this is a delay. That's a delay time. Analytically, it is very difficult to get an expression for this one. So analytically, it's not possible to get an expression for this one. So what we say, for example, if a delay time we consider by setting it 0.5, that means 50% of the response, final response, whatever the value we, and we start solving for the t. It will be very difficult for us to find the expression. So analytically, it's not possible. It is difficult to find the exact analytical expression. To find the exact analytical expression. Okay, so then what we do, an approximate expression we write for it, and an approximate expression for the delay time is given by, so that expression is an approximate expression, that is 1.1 plus 0.125 xi plus 0.469 xi square divided by k omega n, and the 0 should be less than, xi should be less than 1. Now, for example, if we are talking about delay time is obtained by setting c of t response equal to 0.5, and then we solve for the t. It will be very difficult for us to analytically get that expression. So delay time normally is approximated to this expression, which you can use, but mostly we don't use it, delay time. Okay, now let us move to the numericals. Now, okay, I had one numerical. I don't know why I kept that. To begin with, okay. Anyway, delay time is here. I'll get that numerical. So numerical is very simple. We can write it here, no problem. Problem number 1 is, given the transfer function g of s is equal to s square 15s plus 100. This is the transfer function. We need to find TP, peak time, percentage overshoot, settling time, and TR. This is just to get familiar with the numericals. Okay, now let's start the solution of this one. Now, what we have to do, we need to write the general second order system. So we need to write the general second order expression. General second order transfer function. So that general second order transfer function, C of S by R of S was equal to G of S by R of S was equal to G of S, and that is equal to omega n square S square plus 2 xi omega ns plus omega n square. Now what we have to do, the given expression, which is given, G of S is given in the numerical, so we need to compare the values. Comparing equation 1 with given transfer function in the numerical. I don't know who's this. Okay. Now when we compare what we have omega n square equal to 100. So that means omega we can easily get equal to 10 radians per second. Units are very important, I have told you. The next is 2 coefficient of S, 2 xi omega ns is equal to 15. So xi will be 15 divided by 2 into omega n. That will be 15 divided by omega n is 10. So that is 15 by 2 is 7.5 it will be. So that's an underdamped system. If asked in the gate examination what is the type of response, you have to write. So xi value will be 0.75. So one, we have got xi also, we have got this also. So now number one, we have to find peak time. You have to remember these, memorize these expressions. Zabani yaad hone chahiye ye. Peak time, TP, we have derived all those expressions yesterday. Peak time is TP pi divided by omega n under root of 1 minus xi square. Pi is in radians always. So when you substitute the pi in radians, 3.1416 divided by under root, this is 10 under root of 1 minus 0.75 square. Okay. So if you have calculated it, you can use your calculators. So peak time you will be getting as, I think, 0.45475 seconds. So this is the number one question, just to remember the expression. Nothing new in this case. And numerical is very easy, just to get familiar. Percentage overshoot. Okay, percentage overshoot we know. Overshoot value we know. E raised power minus pi xi divided by under root of 1 minus xi square. And when it is percentage, you need to multiply by 100. So you have everything. E raised minus pi, you can use 3.1416. I'm not writing. Xi is 0.75 under root of 1 minus 0.75 square into 100. Use your calculators, engineering calculators, and you can get percentage overshoot. Percentage overshoot is, okay, I think it is 2.838. Just check these values. Okay, let me add a page here. 838. Okay, next we have third. We have settling time. We know the expression for the settling time also. TS is that is 4 divided by omega xi n, omega n into xi, sorry. That is 4 divided by xi is 0.75, omega n is 10. So omega n is 10, yes. So that should be equal to 0.533 seconds. Please check these values. Maybe sometimes there will be some mistakes. You need to check these values. Fourth is your rise time, TR. So rise time is pi minus phi divided by omega n under root of 1 minus xi square. We know pi is in radians. Phi we know. Number of times we have used in the expressions, tan inverse of under root of 1 minus xi square divided by xi divided by tan inverse. Okay, omega n under root of 1 minus xi square. You can substitute the values and you will get it 0.23 seconds. Okay, 0.23 seconds you can get. This is the numerical one, very simple, not a difficult numerical. Okay. Okay, okay, fine. Let's move to this numerical. A unity. No. Where is the numerical gone? Second one. Okay, sorry. This is the second. This was there. We had there numerical. Anyway, it doesn't matter. Second numerical is very important. A unity feedback control system is characterized. This is here. It's characterized. आधा ही आया है. Characterized by open loop transfer function g of s h of s. Determine the system gain k so that the system will have a damping ratio of 0.5 for this value of k. Find the rise time, peak time, settling time, and peak overshoot. Assume the system is subjected. Assume the system is rise time, settling time. Assume the system is subjected to a step of 1 volts. So before solving this numerical, some people, I will ask a simple question to roll number 9. Roll number 9.
Yes, sir.
Now, let me, मैंने कुछ बोला नहीं अभी. I have just named roll number 9. It's a very important things. ये देखो क्वेश्चन मुझे कराने में कोई प्रॉब्लम नहीं है. I can solve thousands of numericals. लेकिन मुझे गेट एग्जामिनेशन पॉइंट से क्वेश्चन कराने जो कि पिछले आए हैं और एग्जामिनेशन व्हाट द गेट पीपल एक्सपेक्ट फ्रॉम यू. दैट्स वेरी इंपॉर्टेंट. सी कंसिडर अ क्लोज लूप सिस्टम विथ अ यूनिटी फीडबैक. लेकिन बना देता हूं मैं यहाँ पे जो बच्चा भी ये क्वेश्चन का आंसर मुझे बताएगा, whosoever student he is, he will provide me the correct answer. I will add 5 marks to his assignments. ठीक है, क्योंकि मुझे देखना है ना कौन रेगुलरली क्लास अच्छी तरह अटेंड करता है और विथ अटेंटिव. I'll ask a question to first to roll number 9, then to roll number 6, then to others, whosoever can participate. सारे बच्चे एक जैसे हैं मेरे लिए. I don't have any. Okay, so this I will be. See, these numericals first was very simple, and then I'm moving towards the gate numericals because my aim is that you should qualify the gate. But the way you are your attendance in the class, I don't think you will be same as 6th semester or 8th semester. Same students. There's no difference. कोई खास difference नहीं है आप में. Some students are good. That doesn't. Majority of the students have to be good. जो कि which was the case in the previous semesters. I was very happy to teach you. But I think I have done a mistake. I should have. Electronic people are very good in control system. I have got the feedback from them also. Anyway, leave it for the time being. Now this is a closed loop system. Input, error, transfer function, output. Everybody knows this. What is the feedback? Feedback is unity. Now, in case of unity feedback system, how we refer, sometimes we say open loop control system. Sorry. Sometimes in a question, they will tell you the open loop control system, open loop transfer function and a closed loop transfer function. Roll number 1, can you explain me what do you mean by open loop transfer? This is a closed loop. See, question here is open loop transfer function, but actually it's a closed loop. Why? What's the difference between these two terminologies? Closed loop transfer function and open loop transfer function. Transfer function I'm talking about, not that previous closed loop system and open loop system which we have talked about. Can you answer this question? जल्दी, मेरे पास टाइम नहीं इतना. रोल नंबर 9.
यस सर. सर इसमें फीडबैक नहीं होता है. ओपन लूप में, क्लोज लूप में होता है.
नो, आई एम टॉकिंग अबाउट द ट्रांसफर फंक्शन.
ये ना फीडबैक लूप जो होगा लूप गेन वो नहीं होगा.
Why sometimes we in a question he's asking open loop transfer and closed loop transfer function. ओपन लूप ही बना देता है, यहाँ पे क्योंकि ओपन लूप बनाता है, फिर तो बात कर रहे हैं हम तो बना रहे हैं, फिर वो हम तो ये बना रहे हैं यहाँ पे. सी, ये नहीं, ये वाला हमने क्वेश्चन अभी किया है. दिस इज अ क्लोज लूप ट्रांसफर फंक्शन, बट एक्चुअली वी आर रेफरिंग टू ओपन लूप ट्रांसफर फंक्शन हियर. ऐसा क्यों है? ओके, यू
हम
शुड
इक्वलिटी
ऑलवेज नो,
फंक्शन.
वंस फॉर एवर इसको याद रखो, ठीक है? ये बड़ा कंफ्यूजन होता है स्टूडेंट्स में. याद रखो ओपन लूप के बारे में मैं क्या कहता हूं, अच्छी तरह इसको दिमाग में रख लो. In case of unity feedback system, GS is referred to as in case of unity feedback system, GS alone is referred to as open loop transfer function, which we will be writing like TOLTF. Okay, a question can arise, sir, how GS is open loop transfer function when it is connected to closed loop transfer function as I have shown above. See, here is a feedback. I can change the feedback. Sorry. Let me change with this rubber. Okay, now let me draw the feedback also. I'm drawing the feedback. Sorry. I'm drawing the feedback here. Okay, that feedback is HFS. Now, if this is unity, then open loop will be referred as GFS. That's what I was asking about the previous question was answered like this, that why sir GFS here, not here, here, GFS. That means there is an open loop transfer function. And that open loop transfer function has unity feedback. It will be written in the question. I have not written it here because just for the sake of getting familiar with the question, I have written this. So once we are talking about, then it will be GS only. So question will arise, sir, how GS is open loop transfer function when it is connected to closed loop? So please have an explanation will be like this. For this explanation is like this. See here, open loop transfer function is always G of S into H of S. This is the meaning of open loop transfer function. Now, if it is a unity feedback, then H of S will become 1. Now, what is the closed loop transfer function? Transfer function of closed loop, closed system, yeah. Transfer function of that we know, just now we have written in previous question is G of S 1 plus G of S. This is a negative feedback we are talking about. Positive will be negative. So this is the transfer function of closed loop transfer function. From the above figure which we have drawn, it should be this figure. It should be very clear if we will open the feedback. Now, suppose I am going to open this feedback. Now, this figure, what I am going to do, I will open this feedback here. Now, what I am doing here, sorry, this I am trying to open. It's not a closed path now. Okay? Here it is open now. Now, open loop transfer function, if I am still going to come, this path is not closed. Now you move from here, this is your output, C of S. You move from here, this output still will be, in case of open loop transfer function here will be equal to G of S, H of S. But for closed loop now, because the loop is open now, we cannot have this type of expression. So open loop transfer function is term not from open loop system, but it is from the closed loop system. Therefore, what we need to conclude? So open loop transfer function still will remain, OLTF will remain G of S, H of S if I open the loop. So open loop transfer function is a term which is not from the open loop, but it has been taken from the closed loop. Therefore, what we conclude that if a closed loop system is open, if a closed loop system is open, in a sense that we have a negative feedback, and negative feedback is not connected to form a closed loop. I'm repeating again. We need to conclude here, and we can say that if a closed loop system is opened, just now I opened it, in a sense that negative feedback is not connected to form a closed path. Just now I have shown negative feedback is not closed to form a, not connected to form a closed path. Then product of G of S into HFS as shown in this figure which I am talking about will be treated as an open loop transfer function. This is ever you have to remember it. We don't take open loop term from the closed loop. Sorry, open loop term from the open loop system. We take it from the closed loop system. But only thing is, we don't connect the negative feedback to, we don't connect the negative feedback, but we still have a feedback. We don't connect it, but open loop term can be written as G of S, H of S. If it is unity, it is alone G of S into 1. So this thing has to be remembered forever. Please make it a point. Okay. I hope roll number 9 you have got everything clear.
Yes, sir.
क्लियर हुआ कि मेरा कहना फजूल था?
Yes, sir. आया समझ.
Okay. Now let us talk about the questions now. Now I'll solve this question and then we'll go for the gate numerical. Okay. Now this question says, it's a very simple question I've taken from one good book. A unity feedback control system is characterized by, see, now it is open loop. आपको हमेशा ये question system close में लेना है, लेकिन this is open loop transfer function. What is open loop transfer function? G of S, H of S. So that means it's not a unity feedback. Sorry, it is unity feedback. That means H of S is 1. Unity feedback control system is characterized by open loop transfer function. So we have what we have a, I can just copy this. I think this you have noted down, and this I will try to rub. These are very important things. People get confused. Sir, open loop to closed loop kahan se? These things should be clear. You have to clear these things. Just a second. Why it's not? Okay. Now you can see here. Now I'm closing it. Okay. So this is a given question. It's a unity feedback. So we'll be drawing the unity feedback. Okay. Just a second. Now we have a unity feedback, and what we are having here, so we have here second order transfer function that we have defined as omega n square. Already I have shown it to you, s square plus 2 xi omega ns. Rest you can compare G of S 1 plus G of S H of S. You will get it other function. So it is unit representation was like this. Now, in order to solve this question, what we have to now from now onwards for the reference which is shown in figure, okay, the characteristic equation will be given by, how it will be given by, it will be given by 1 plus omega n square divided by s square plus 2 xi omega ns. That should be equal to 0. This is the way to write a characteristic equation. So if we solve this, we'll be getting, or s square plus 2 xi omega ns plus omega n square should be equal to 0. Now let's call it equation number 1. The above, you have to write it for the all other questions. The above equation 1, that is this equation 1, will now onwards be referred to as the reference characteristic equation. So this will be treated as the reference characteristic equation. Now in general, how we write it, the characteristic equation for the present problem or numerical is, so generally we have to write 1 plus g of s, h of s is the general characteristic equation. Now in context to this question, what is the question we have above? So here we have g of s, h of s, this. So 1 plus g of s, h of s will be, therefore, or 1 plus, what was this, k divided by, we can multiply the s square plus 10s. Okay, I think this is correct. Yes. S square plus 10s. Yeah, fine. Will be equal to 0. Now solve this, will be equal to 0. So you can solve this, s square plus 10s plus k will be equal to 0. Set second equation. Now we have to compare the general characteristic equation is this one, equation number 1. Comparing equations 1 and 2. Comparing equations 1 and 2. So it will be 2 xi omega n will be coefficient of, this is 10, okay, and omega n square is equal to k. So we have to find all those things: settling time, rise time, peak time, settling time, and peak overshoot. Same we have got already. We have a step input that we know already. Okay, so I will add a page here. Now this is the way we have. But number 1, before going that, let us solve this. Xi is given. I think xi is, yeah. We have a damping ratio. He has to give it. Otherwise, will not be able to find the value. Uh, so that the system will have a damping ratio of 0.5. So xi is given to us. Xi is 0.5. That means it's an underdamped system. So when xi is 0.5, therefore we can get omega value. Omega n from the above will be 10 divided by 2 into 0.5. And that omega value we'll be getting is 10 radians per second. Okay, that will be 10 radians per second. So Omega is 10, so value of k can be, we can get k is omega n square. So k is omega n square, that is 10 square, that will be 100. So value of k also we have got, this is a constant value, 100. Okay. Now we can find other values. Number one, we have to find the rise time. Rise time, we know rise time is tr, and that is pi minus phi. Phi we will directly write tan inverse of under root of 1 minus xi square divided by xi divided by omega n under root of 1 minus xi square. See, please, I don't have here time to find the write the values in this case. I will be giving the answers only. I think this much of calculations you can do, because if we have to do lots of numericals, then this much you should be do. I think it's ठीक है Tanzib. Calculations can you do, or I
Yes,
have
sir.
to do?
Easy.
We don't have so much of time. Okay, number two is a peak time. Peak time is TP, and that peak time is pi divided by omega n under root of 1 minus xi square, and this you are going to get 0.363. You have value of pi is in radians, omega n you have, every value you have, you can substitute the values. Now third we have, third what we are having? So third we are having a settling time. Settling time is T of S. Settling time is 4 divided by xi omega n, and that is the value is 0.8 seconds. And last we have percentage overshoot, or we also call it peak overshoot. Peak overshoot is MP, and that value is E minus pi xi divided by under root of 1 minus xi square. If you want to multiply by 100, you can multiply and you can get the value 0.163. Peak overshoot is 0.163, and that is 16.3% is the peak overshoot. So characteristic equation have to be remembered now, how to write this and then how to solve this numericals. It's a very simple. Now, let me take a one graphical numerical and then we will go to the gate numerical. Okay, see here. Okay, roll number 6. I need
Yes, sir.
answers now. Okay. Now, what is this? It's a very simple question. The unit step response of a control system is shown in figure. Response is already given to you. Now, earlier you had been asked to form the transfer function, and you have to obtain the response. Now, response is given to you, and now you need to find the transfer function. Transfer function earlier was given. Find the transfer function of the prototype system. That is, I already told what is a prototype system. That's a replica of the exact system with some assumptions. With some assumptions, we cannot have an exact system. Prototype system used to model a second order system. Now this is C of t 1.1631. This is peak overshoot here. Sorry, this is a peak value. This is a what you call steady state value, and this is a peak time. Everything you have to know from the graph, and you have to find what, you have to find the transfer function. Now how we will proceed? जल्दी इतना टाइम नहीं है.
सर पीक ओवरशूट की फॉर्मूला से हमें निकल सकता है ना,
कितना
ये
है पीक
टाइम
ओवरशूट,
यूज जो
कितना
कर
है?
दिया है
ओके, आई विल
वन
राइट हियर.
0.16.
वेरी गुड, 0.163. दैट्स ऑल. ये हो गया तो दैट मीन्स क्वेश्चन आ गया. फ्रॉम द above figure, peak overshoot MP is equal to 1.163 minus 1 हो गया, ये 0.163 आपका हो गया पीक ओवरशूट. पीक ओवरशूट आ गया तो MP is given as MP is e raised power minus pi xi divided by under root of 1 minus xi square. So that is equal to how much one? 0.163. So radian value, pi value, you can substitute and you can get the value of xi. So applying the log on the both sides. So that will be pi xi divided by log m by n will be this one. Okay. So log is 1. Okay. Log m raised power n log m. Log is 1. I'm not writing that. Equal to natural log of 0.163. So if you solve this here, therefore the value of xi which we are going to get here is zero point 0.5. Value of xi is 0.5. So again, second thing also is given in the graph, that is this is what? This is a peak time. Also from figure we can find the peak time. TP is equal to point कितना है ये 0.363 0.363 seconds. Okay, therefore 0.363 will be equal to TP होता है pi divided by omega n under root of 1 minus xi square. So we don't have omega n, pi value we can substitute, omega n we don't know, xi value we have 0.5 square. Only unknown is omega n value we can find, that will be 10 radians per second. So this is the approach how we have to find the various values. So you need to, this is the approach, two things will be given, xi value you can find by this maximum peak overshoot, and then peak value we can find omega n. Now hence the transfer function of prototype system is C of s divided by R of s is equal to omega n square divided by s square plus 2 xi omega n s plus omega n square. So that value you substitute the various values. Omega n will be 100, s will be s square, 2 xi and omega n 10 into 0.5, that will be 5. Sorry, 10 into xi is how much? 2, 10 into 20 into 20 into 0.5 is 10. 10 s plus 100. So this is the transfer function we require. So you can have a question in any type. Either you'll be given graphs. So second graph is here. You need to solve this numerically yourself. Okay. Now I have another numerical. Let me check. Yeah. Gate 2001, this numerical was asked. Very good numerical. Not a difficult numerical. They will ask very simple numericals only. The open loop DC gain of a unity negative feedback system with a closed loop transfer function. See, open loop. Now, open loop DC gain you have to find. See how language is written. Open loop DC gain of unity negative feedback system with a closed loop transfer function. Okay, with a closed loop transfer function is given. Closed loop transfer function is given to you, but you need to find the open loop. So let me copy this figure here. I don't need to draw it again. Where I have drawn that. Okay, let me copy this because otherwise waste the time. Okay, copy. paste it here. Okay. Okay. So what I have to now I will be what I'm trying to draw. Okay. Now this is G of S. Sorry. This is your G of S. Okay, C of S, R of S, error is fine there. So we are drawing now, this is what? The negative unity feedback system. Here I can write drawing the negative unity feedback system. Okay, so we have the question like this: the open loop DC gain of a unity negative feedback. This is a negative feedback, but I have used what is the term open loop will come from the closed loop system, but closed loop transfer function is given to us. So closed loop transfer function, have a look. Closed loop transfer function, we can denote it CLTF, is what is basically C of S divided by R of S, and that's given in the question. What is that? S plus 4, which is equal to basically what? Which is equal to basically G of S. Let me write it complete, plus G of S, H of S. H of S is here 1. So we'll be writing that. Okay. So now C of S, before simplifying it, R of S will be given as G of S divided by 1 plus G of S. H of S is because H of S here is 1. Unity feedback is there. So G of S 1 plus G of S, okay, H of S is 1, so we are not writing that, will be equal to what is given. The closed loop transfer function is given to us, S plus 4, S square plus 7, S plus 13. S plus 4 divided by S square plus 7S plus 13. It's given to us. Let's have this in equation number 1. So here open loop transfer function is what? Therefore, here open loop transfer function is equal to G of S into H of S. But in our context, H of S is 1, so it is G of S. Why? Because it's so unity feedback. That's the reason here. Okay. Now, in case of unity feedback, open loop transfer function, in case of unity feedback, you should always remember open loop transfer function is G of S. No need to write above terms. This is for your knowledge I am writing, otherwise I don't need to write. So from equation what we can get, we can cross multiply it. G of S will be S square plus 7S plus 13, which will be equal to 1 plus G of S multiplied by S plus 4. Okay, so only unknown in this case is G of S. So you can bring that here, G of S, S square plus 7S plus 13 minus G of S. Okay, G of S, S into 4 will be one term. G of S, S plus 4. Okay, that will be equal to S plus 4. I don't, without G of S, I'm going to write on the right hand side. So I can check G of S common. G of S, I will take common, S square plus 7S plus 13 minus S minus 4 will be equal to S plus 4. So S square 7, 13. So this will be 6x, 13, 9. So that's what we will be getting. So we can write here G of S directly equal to S plus 4 divided by S square plus 6x plus 9. Okay, so G of S we have got. Now, what's the question asking? What is G of S? It's open loop transfer function with a unity feedback. So, what's this? I'll be writing this again for your knowledge. Open loop transfer function with unity feedback will be given as G of S, and that value we already know now is S plus 4, S square plus, yeah. Roll number 6, what do you mean by the question he has asked is with a closed loop function, the DC gain of unity. DC gain means what? Rule number 6.
Yes, sir.
DC gain
Out,
means-
output by input.
No, डीसी गेन वो गेन होता है। डीसी गेन की बात जब होती है तो फ्रीक्वेंसी हैज टू बी जीरो। बिल्कुल सिंपल टर्म है ये, क्यों नहीं आता आपको? ओके, सो डीसी गेन ऑफ open loop transfer function will be when your frequency, this is frequency domain, it will be 0, that is 0 plus 4 divided by 0 plus 0 plus 9. So your correct option out of this should be 4 by 9. Roll number 9.
Yes, sir.
Now, if I am asked to find the DC gain of closed loop transfer function, closed loop transfer function भी हमने निकाला है, what will be
Yes,
the
sir.
answer?
ये 1 plus ये
क्या
1
1
plus
plus?
1 plus 4 by 9.
मुझे आंसर बताओ। आई डिडंट आंसर।
13 by 9.
13 by 9 कहां से होगा? What is the closed loop transfer function?
Closed loop transfer function.
क्लोज लूप, ये तो ओपन लूप है, क्या बोल रहे हो? क्लोज लूप मैंने अभी निकाला कहीं पे, दिस इज द क्लोज लूप
4 by
ट्रांसफर।
13. 4 by 13.
4 by 13, देन व्हाई यू आर सो मच कंफ्यूज्ड?
No, sir.
S plus 4 क्लोज लूप ये है, ये क्वेश्चन पूछने का तरीका है गेट एग्जामिनेशन, वो इजी क्वेश्चन पूछते हैं लेकिन। So S will be 0, that is 4 by 13. But our answer is not 4 by 13. Our answer is this one. Why? Because he has asked for an open loop. See, question क्या है? Open loop DC gain of a unity feedback system with a closed loop. Transfer function closed loop दिया है, लेकिन उसका open loop बताना है। तो आपको simply open loop transfer function बनाना है, उसको DC gain निकालना है। I hope this question is very simple. इसमें कोई difficult नहीं है। Okay. Let's move to the another numerical. Okay. We will be talking, बहुत सारे न्यूमेरिकल है लेकिन टाइम नहीं है हमारे पास। दिस इज गेट के न्यूमेरिकल बहुत सारे हैं। सो ये हमने किया। तो फोर्थ यू विल बी डूइंग योरसेल्फ, दैट इज फॉर योर होमवर्क। नाउ फिफ्थ इज मेजरमेंट कंडक्टेड ऑन अ सर्वोमीटर, ठीक है, shows the system। अब हमें सिस्टम दिया गया है। when the system is subjected to what? Step unit, step input of 1 volts, obtain the expression for the closed loop transfer function, ठीक है, determine the undamped natural frequency and the damping ratio, number 2, fine, number 3, obtain the unit ramp response। तो ये 3 चीजें आपको निकालनी आनी चाहिए। ओके, तो we have any other gate numerical है या just let me see। ये आसानी क्वेश्चन है, ये डिफिकल्ट नहीं है, इसमें कैलकुलेशंस है, लेकिन ये गेट एग्जाम में नहीं आ सकता। ऐसा आ सकता है एक आधा पार्ट। ये क्वेश्चन आप कर सकते हो। रुतबा 27, रोल नंबर।
अस्सलाम वालेकुम सर।
कैन यू डू दिस क्वेश्चन?
सर मैं देखूंगी।
नहीं, देखना नहीं है, यहीं पे बोलना है।
सुबह।
रोल नंबर 16।
यस सर।
क्या नाम है बेटा आपका? रोल
अस्सलाम
नंबर
वालेकुम
16।
अस्सलाम वालेकुम सर।
वालेकुम सलाम। कैन यू डू दिस क्वेश्चन?
सर मैं ट्राई करूँगा।
इसमें क्या रिस्पांस दिया है, इसका आपको CS बाय RFS निकालना है, ठीक है। रिस्पांस है हमारा, लेट मी डू इट, लगता आपको आता होगा। रोल नंबर 9, कैन यू डू इट?
Yes, sir.
तंजीब, तुम्हें आएगा? See, number one given is what? C of t is given how much? 1 plus 0.2 e raised power minus 60 है ये. 60t minus 1.2 e raised power minus 10t. Tanzib, can you do it? वो
Yes,
कौन
sir.
है? R of t is equal to U of t. Step input है ये. Okay. Now, first is C of S by R of S we have to find. C of S क्या है? इसका 1 का लैप्लस जब आप निकालते हैं 1 का लैप्लस है 1 बाई एस. 0.2 का लैप्लस क्या हो जाएगा? 0.2 डिवाइड बाई एस प्लस. सिंपल लैप्लस, इनवर्स नहीं निकालना है. एस प्लस 60. इसका क्या हो जाएगा? -1/2 एस प्लस 10. ठीक है. Divided by what is the input? Input is step. That means that is 1 by s. Step 1 by s है. तो सॉल्व नहीं करूंगा मैं, इसको सॉल्व खुद करना पड़ेगा आपको. C of s part A is C of s by R of s will be equal to 600 divided by s plus 10 into s plus 60, I think. Yes. प्लीज यू नीड टू चेक दिस है. ये कैलकुलेशंस तो आपको आती होंगी, इसमें तो कोई खास नहीं है. सेकंड पार्ट क्या कह रहे हैं? अनडैम्प नेचुरल फ्रीक्वेंसी एंड डैम्पिंग रेशियो. सेकंड पार्ट के लिए सेकंड पार्ट वी नो C of S by R of S, we can multiply them and we can get 600 divided by, this will be S square plus 70S plus 60, sorry 600. इसको मल्टीप्लाई किया हमने डिनोमिनेटर को. एस स्क्वायर, फिर आया 60s, फिर आया 10s, 60 और 10s 70s, और फिर 60 into 10 हो गया 600. इट इज वेरी सिंपल. सो वी कैन राइट इट लाइक दिस. इसको हम 600 डिवाइडेड बाय एस स्क्वायर प्लस 70s को हम कॉमन निकाल लेते हैं. इट विल बी 1 प्लस 600 डिवाइडेड बाय एस स्क्वायर प्लस 70s. ठीक है, उस फॉर्म में, ट्रांसफर फंक्शन के फॉर्म में. किस फॉर्म में है? दिस इज क्लोज लूप ट्रांसफर फंक्शन g of s 1 plus g of s into h of s. So g of s is 600 divided by this 1 plus g of s, h of s is unity. Fine. Therefore the system characteristic equation is given by 1 plus g of s, h of s is equal to 0. So 1 plus g of s, h of s is equal to what? g of s आपका ये है और h of s आपका 1 है. 600 g of s यही है आपका. s स्क्वायर प्लस 70s, h of s आपका 1 है. तो दैट विल बी इक्वल टू 0. दिया होगा इसने यूनिटी फीडबैक. सरोमीटर मैकेनिज्म. ओके, yeah, step input we have taken. Okay, he has not given us h of s, so we'll be taking simply 1 plus g of s. Denominator simply लेंगे 1 multiplied by 1 यहाँ बन जाएगा ना. So that's why we are taking simply, we have to multiply it by 1 here. So that's what, comparing these two expressions, it should be 1 here. So that's why unity we are taking. So this is s square plus 70s plus 600. That will be same whatever the denominator is. लिखने की जरूरत नहीं है. Let us call it equation number 1. Now comparing the above equation with the equation 1 with the reference characteristic reference characteristic equation, which is 1, which is s square plus 2 xi omega ns plus omega n square should be equal to 0. Okay. So if we compare it, omega n square is equal to 600 and 2 xi omega will be 70. So we can solve them. Omega n will be getting 24.5. Calculator use कीजिए please अपने radians per second, and xi will be getting 1.4. That's an overdamped system. We'll add a page here. Okay. Then last question क्या बोल रहा है? Obtain the unit ramp. तो ramp response आप करेंगे खुद ही. That means C of S should be 600 divided by S plus 10, जो भी था x plus 60 था शायद 600 आया था ना ये, into RS. Okay. So RS now unit ramp will be 1 by S square. So you need to solve that and find 600 divided by S plus 10 into S plus 60 into 1 by S square. So you need to solve that and you need to obtain the response, that is C of t you have to obtain. So I hope this you can do. I will keep this for your homework. C of t you have to obtain. Is it fine? Fine, roll number 9.
Yes, sir.
Tanzib, you can send me log, okay? So we'll continue.
Okay, sir.
Let me first stop the